Let's read the problem. In the adjacent figure, triangle ABC is right angled at C and DE is perpendicular to AB. Prove that triangle ABC is similar to triangle ADE and hence find the length of AE and DE. So what is given is that it's right angled at C. So this is given to us. And DE is perpendicular to AB. So DE is perpendicular to AB. So that's given to us. This is right angle here. Then prove that triangle ABC is similar to triangle ADE. So we have to prove that this big triangle ABC is similar to triangle ADE. Okay. And hence find the length of ADE and DE. Now first to prove that they are similar, you can see that in triangle ABC and triangle ADE, angle A is common and angle AED is equal to angle ACB and they are 90 degrees. Okay, so therefore triangle ABC is similar to triangle AEE. Next, we can see that it's a right angle triangle. ABC is right angle triangle. Okay, therefore by Pythagoras theorem we can say the hypotenuse, which is AB squared, is equal to AC squared plus BC squared, and our AC is 5 squared plus BC is 12 squared, so that is 25 plus 1, 44, and that is equal to 169. Okay, so we have AB squared equal to 169. Therefore our AB is equal to square root of 169, which is equal to 13. Alright, next we have to prove, or we need to find the length of AE and DE. Okay, AE and DE. Okay. So to do that, since the two triangles are similar, their sides are proportionate. The ratios of the sides are proportionate. So I can say that AB over AD, AB is proportionate to AD, is equal to AC over DE, that's equal to BC over AE. Okay, so now let's substitute all the values here. So that would mean, now my AB is 13 and my AD is 3. AC is 5 and our DE we need to find. Then BC is 12. We need to find our AE. Okay, now let's take the first two and then let's say these two, and we can say 13 by 3 is equal to 5 by DE, which implies DE is equal to 5 times 3 over 13. 15 by 13. So that's our DE. Next, let's take this term and say our 13 by 3 is equal to 12 by AE, which implies our AE is equal to 12 times 3 over 13, and that is 12 times 3 is 36 over 13. So you can further simplify this as 2.7, and this will be equal to 1.1. So that's our result. Okay, let's read the problem. In the adjacent figure, triangle ACB, which is this triangle A, C and B, is similar to triangle APQ, which is this triangle A, P and Q. If BC is 8 centimeter, so let's mark them here. Now if BC is 8 centimeter, PQ is 4 centimeters, this is 4 centimeters, BA is 6.5 centimeters, 6.5 centimeters, AP is 2.8 centimeters, this is 2.8 centimeters. Now we need to find CA and AQ. CA and AQ we need to find. Okay. Now given triangle ACB is similar to triangle APQ. Therefore, the ratio of the sides are equal. Okay. So let's write the ratio of the sides now. AB by AQ is equal to BC by PQ is equal to CA by AP. Okay, the sides AB is similar to AQ and our side CA is corresponding similar side of AP, and then BC and PQ are the corresponding similar sides. Okay, so their ratios are here. So let's start to substitute their values. Now AB is 6.5 and our AQ is, we don't know, we need to find. Our BC is 8, PQ is 4, and our CA is, we need to find, and our AP is 2.8. Alright, so let's take these two first. So we can say 6.5 by AQ is equal to 2, because 8 by 4 is 2. So we can say AQ is equal to 6.5 by 2, and that will be equal to 3.25, and this will be centimeters. Similarly, let's take the next two. So we can say CA by 2.8 is equal to 2, which implies CA is equal to 2 into 2.8. That's equal to 5.6 centimeters. So that's our results. You can write it down here more clearly. AQ is equal to 3.25 centimeters and CA is equal to 5.6 centimeters. values. Let's read the problem. In figure OPRQ, which is OPRQ, is a square and angle MLN, angle MLN is equal to 90 degrees. Prove that the triangle LOP is similar to triangle QMO. So let's try and solve the first one first. So we have two triangles, which is we need to prove that triangle LOP is similar to triangle QMO. So in the triangle LOP, you can say that the angle OLP is equal to the angle OQM in the second triangle, and they equal to 90 degrees, and also angle LOP is equal to angle OMQ, since they are corresponding angles. Okay. So since there are two angles similar, we can say that the triangle LOP is similar to triangle QMO. So let's go to the, you can say by AA property. Let's go to the second one, which is we need to prove that triangle LOP is similar to triangle RPN. LOP similar to RPN. Okay. So using the same method, we can say that the angle OLP is equal to the angle PRN, and that's equal to 90 degrees, and also angle PNR is equal to the angle LPO, as they are corresponding angles. Okay, so therefore triangle LOP is similar to triangle RPN using the angle property. So the third is we need to prove that the angle triangle QMO is similar to the triangle RPN. So we need to prove this is similar to this. But we know that this is similar to this triangle and this is similar to this triangle. Therefore, these two are similar. So let's say triangle LOP is similar to triangle QMO, and triangle RPN is similar to triangle LOP. Therefore, triangle QMO is similar to triangle RPN. And our fourth question is find or prove QR squared is equal to MQ into RN. Okay, so what we're going to do is QR is the side of the square, which is QRPO. Okay, so this is a square. Now we know that this side is equal to this side, which is equal to this side. So if we're able to do proportions using these two triangles and somehow multiply OQ by PR, that will be equal to our QR. So that's our objective. So let's try and So since OMQ and PRN are similar triangles, we can say that the sides are proportionate. Triangle OMQ is similar to triangle PRN. So therefore, we can say MQ by RP is equal to OQ by RN. Okay, so further multiplying MQ into RN is equal to OQ into RP. Now our OQ and RP are both equal to QR. So I can replace this with QR and this with a QR. So it will become QR squared. So we can say our QR squared is equal to MQ into RN. And that proves our requirement. Okay, now let's read the problem first. If triangle ABC is similar to triangle DEF, such that the area of triangle ABC is 9 centimeters squared and the area of DF triangle is 16 centimeters squared and BC is equal to 2.1 centimeters, find the length of EF. So let's consider two triangles here, ABC and another triangle DEF. Now the area of this triangle is given to be 9 centimeters, okay, and the area of this triangle is given to be 16 centimeters squared. Now the shapes are not to scale, this is just for representation purpose. Definitely this is a bigger triangle. Okay, now we are given that BC is 2.1. Alright, so then the corresponding side of the triangle DF to BC will be EF. Okay, since our triangle ABC is similar to triangle DF, so let me start by saying since triangle ABC is similar to triangle DEF, the ratio of their areas, which is area of triangle ABC over the area of triangle DEF will be equal to the ratio of the squares of any one side. So I can take BC squared over EF squared. Okay, so this we know by property of a similar triangle. Okay, so we know BC is 2. So we know BC, we know this area, we know this area. So let's substitute the values here. 9 over 16 is equal to 2.1 squared divided by EF squared. So we need to find EF. Okay, so our EF will now be equal to, EF squared will be equal to 16 by 9 times 2.1 squared. Okay, now we can take the square root on both sides and say our EF is equal to 4 by 3 into 2.1. So further that is equal to 8.4 by 3, which is equal to 2.8 centimeters. So therefore, our EF is equal to 2.8 centimeters. Okay, let's do the last one in this video. Two vertical poles of height 6 meters and 3 meters are erected above a horizontal ground AC. Find the value of Y. So we're given this diagram, and PA is the 6 meter pole and CR is the 3 meter pole, and AC is the distance between the two poles, and we need to find Y. Okay, so we can see here triangle PAC is similar to triangle QBC. Since they have two angles equal, they have 90 degree here, and you also have this as a common angle for both. So you can see here by angle property. So the ratio of the sides are equal. So let's put the ratio of the sides. So let's say PA by QB is equal to AC by BC. Okay, so further we can simplify this as, since we know PA 6 by our QB is Y is equal to AC by BC, and further we can say that Y times AC is equal to 6 times BC. Okay, we'll keep this as 1. Next, let's consider triangle ARC, which is this triangle here, and it's similar to the triangle AQB, using the same property of two angles which are equal. So again, we can find the ratio of the sides. So we can say CR over QB is equal to AC over AB. Okay, CR by QB is equal to AC over AB. Okay. Now we know CR is 3, so 3 by QB is Y is equal to AC by AB. So we can say Y into AC is equal to 3AB. So let's keep this as 2. Now from 1 and 2 we can say, from 1 and 2 you can say that 6BC is equal to 3AB, equating these two because they are both equal to YAC. So we can say our AB is equal to 2 times BC. Okay. Now from the picture you can see that AC is equal to AB plus BC. So our AC is equal to AB plus BC. So substituting the value of AB here, you have AC is equal to 2BC plus BC, and that will be 3BC. Okay. Now let's substitute this value of AC. AC is equal to 3BC, which is 3 in 1. So you have YAC is equal to 6BC. So substituting the value of AC as 3BC, you get y into 3BC is equal to 6BC. Further simplifying, y is equal to 6BC by 3BC. BC and BC will be cancelled. You get 6 by 3, which is 2 meters. Therefore, our y is equal to 2 meters. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.